Hey everybody, I'm going to go over the 7.2 book work, but with a homework quiz. So if you're struggling with the book work or if you check your answers and some of them are wrong, hopefully this can help you fix the problem. So here's just from the textbook, the summary at the end, and a few things to highlight that you should include in your notes is if you have a sampling distribution of p-hats. Hopefully you watch the AP Stat Guy video. That means you take a bunch of samples and you calculate a sample proportion. And infinite samples of the same size from the same population, all of those proportions, the mean of that distribution would be the same as the population proportion or what the proportion was known to be. The standard deviation would be the square root of p. We use q, pq over n, but 1 minus p is how we find q. And then the two conditions we'll have to check before we can use a norm CDF is the 10% condition that allows us to use the standard deviation, and then the normal condition, which allows us to use a normal curve. So every problem you use with these p-hats, you need to check those two conditions. So here's the 7.2 homework quiz. It's not a grade. Again, it's just optional. This is, according to a poll, 22% of high school students in the UK say that Dobby is their favorite character in Harry Potter books. Let's assume this parameter value for the entire population of high school students in the UK. You take a sample of 150 school students and record the proportion p-hat of individuals in your sample who say Dobby is their favorite character. So the information they gave us was the population proportion p. Your calculator doesn't understand percents. So 0.22, and they gave us n was 150. And in part A, what are the mean and standard deviation of the sampling distribution of p-hat? Well, the mean of the p-hats, and notation's important, that's equal to the population parameter p, which is 0.22. And then the standard deviation, technically before I find it, I'd have to check the 10% condition and write it out in words. So I'm just going to say, though, 150 high school students is likely less than 10% of all students in the UK. So we'll say 10% conditions met. That means the standard deviation of the p-hats will come from the square root of pq over n. And here, that's 0.22, well, 22 times 0.78 over 150. And I looked at my answer key, that should give you 0.034. And then B, what's the approximate shape? Well, hopefully it's normal, but you have to check the normal condition. So NP, if you do NP here, that's 0.22 times 150, or 150 times 0.22, you should get 33. And that's good. The normal condition has to be greater or equal to 10, so greater than 10, and we got 33. Oops. So that's good. And then NQ is 150 times 0.78. And that should give you 170. And that's also, so those are both greater than 10, so that condition's met. That means the shape of this distribution is normal. Suppose our sample size was 36 instead of 150. Compare the shape, center, and spread. Well, the shape, we have to recheck the normal condition, so now it would be 36 times 0.22. That gives you 7.92. So that's not good. That means it fails the normal condition. So we really can't say what the shape is. So that's less than 10, so that's bad. So the shape is not normal. The center, though, will still be the same as the population proportion, so that didn't change. So the mean's still the same. And then the standard deviation here, if I put a 36 in the bottom of a fraction instead of the 150, you kind of intuitively know it's going to be a bigger standard deviation. And obviously the 10% condition here is met because if 150 was less than 10%, 36 is also less than 10%. Here's a big square root. So you end up getting 0.69 or 0.069. So you see the standard deviation is larger. So the shape is non-normal. The center is the same at 0.22, and the spread, the standard deviation is increased. It's a bigger spread of 0.069. Part D, a small town in the UK only has 600 high school students. What is the largest possible sample you can take from this town and still be able to calculate the standard deviation of the sampling distribution of p hat using the method presented in the textbook? So this is saying the 10% condition. So if the population is 600, and I want to find 10% of that, that's going to give me 60. So 60, anything bigger than 60 is larger than 10% of the population. So the biggest sample size you could take here and still satisfy that is 60. All right, here's another one dealing with proportions. And I'm going to really show my work and stress how I can tell if you're finding your answers from a dishonest source, just so you can check yourself when you hand in a quiz or a test. So here's a power company. They trim trees growing near their lines to avoid power failures. Applying a chemical to slow the growth of the trees is cheaper than trimming, but the chemical kills some of the trees. Suppose that such chemical would kill 20% of sycamores. So that's going to be our population proportion P. The power company tests the chemical on 250 sycamores. There's N. Consider these an SRS. So that's good. Simple random sample from the population of all sycamore trees. What are the mean and standard deviation of the proportion of trees that are killed in a sample of 250 trees? So the mean of my p hats is the same as the population P, and that here was 0.2. The standard deviation, I got to check 10% condition. I would say 250 sycamores is less than 10% of all sycamores. You have to write that, but I'm writing with my fingers, so I'm just going to put a check. That means we can calculate the standard deviation. So the sigma of the p hats. If I do the square root of 0.2 times 0.8 over 250, we get a standard deviation of 0.025. And then next part, we're going to use this. So we want to calculate a probability. Well, how can I do that? Is this binomial? Is this geometric? Or is this normal? So hopefully it's normal. So you got to check the normal condition first. So NP here, if you calculate NP, NP here, if you do 0.2 times 250, you get 50. And if you do NQ, that's 0.8 times the 250, you get 200. Those are both greater than or equal to 10, or greater than 10, so we're allowed to use a norm CDF. So this is normal. And it's going to have the mean from up here and the standard deviation from up here. So I know this is normal, so I draw my curve. The mean's in the middle, it's 0.2. I want to know that at least 60 or 24%, this is the p hat we're interested in, 24% of the sample is killed. So at least 24% is up here somewhere. At least means that or more, so I shade to the right. And then this is just a norm CDF. So my lower bound's 0.24, my upper bound's George Sink. Mean was 0.2 and the standard deviation was 0.025, I believe. And I get 0.055. So pretty close to being unusually unlikely there. That's only 5.5% of the time that 24% or more of those trees would be killed if this is the true proportion of trees that die when this chemical is applied.